All right, let's begin. These are the exam question answers, solutions to the 1D, if you still kept that sheet, past exam questions for 1D. So if you thought you understood, check. Okay, every PowerPoint, so we're on 1E, will have solutions for 1D. If we're in 1F, it has solutions for 1E. Okay? So make sure to just have a look as your time. If you have any questions, come and see me, yeah? So I can explain it in my own time too. Right? Today's exercise. Still again, 1E on composite functions. Those are the points I've talked about. Now let's go back to what I was trying to describe. I said it was a function within a function. I gave you these two functions here, and I said this is called f of g. I said that you have two functions. What you're really doing is you're putting g of x, which I want you to remember, this is your y value, and this is your x value. Okay? What you're doing here is you're substituting a y value into the machine for f of x. And the way I tried to describe it yesterday was I said this. I said you have two machines. You've got g of x and you've got f of x, which gives you the final result of h of x. So when you say h of x is equivalent to whatever f of x is, sub g of x in, what you're really doing there is you're substituting the y values for g of x. And the y values, we call that the range. Okay, we call that the range. I'm going to write it underneath so remember. I'm going to write it in red. This is the range of g. Okay? So what you're really doing is you're substituting the range of g into, notice this is the domain, because those are the x values. Without the g of x, that's the x values you're substituting in. So that becomes the domain. So right here, when you substitute it in, it happens to also be the domain of f. That's what you're really doing. So visually, if I can show you what it means, what goes into the machine is called your domain, true? So that's x. Goes into g of x, comes out as y values, but those y values are now being put into f of x. That's why it is now the domain of f. But the y values is really range of g. Okay, that's the concept. And so when it goes into f of x, it spits out the y values for f of g. And that f of g technically tells you the y values for h of x, which is what this is. That is your y, and that's your x. And that is why the domain of g of x is equivalent to the domain of h of x, which is someone yesterday mentioned about that. Yes?
So why can't you have, why is it not allowed to have like by substituting in the function, it has a different domain?
Tell me that line again. Reword that line.
Why does the range of the I don't know what the name of the function. For f of g of x, why does g of x have to have a equal to, why does it have that rule of like f range of g is subset or equal to domain of f? Why is that a thing?
Okay, all right, good. We'll pause on that, okay? But let's just to start. Does this make sense so far? In terms of the machine, I haven't talked about restrictions yet, so we're not talking about subsets yet.
Why is it bad to have the restrictions?
Okay, and that's in the next slide, where I'm going to explain. But what I needed you to understand was the pathway. Okay? The pathway that I wanted you to understand was x comes in. This is the domain. I'm going to rub this off. This is the domain. I'm going to write here. Domain for g of x comes in. I'm going to do the yellow line so you can see the process. Domain of g of x comes in. What comes out is the range of g of x. This range of g of x is substituted into the domain of f of x. I'm going to draw the arrow so you can see again. So it goes in, becomes the range of g. You sub the range of g, and that's the key step here, which is what the restriction will come in about. This is the range of g. gets put into the domain of f, and that then spits out your function, which is h of x. Then you see a picture, which is a dot. Okay, that's why that's the image. That's the process so far. So domain of G, you put any value in, 1, 2, 3, 4, goes in, spits out the range of G. It could be 10, 11, I don't know what it is, right? Spits out a number. That number is then put into the domain of f. Then after the domain of f, it spits out a y value for f. But that actually is the image. Okay, so the bottom is the image. And that is the picture of what we call the composite function. Now, let's go to the next slide. So that's the picture of the machine. Okay? Let's have a look at now why it now becomes this property where you have what Josh is trying to ask, why you have range of G needs to be a subset of the domain of f. Okay, because we understood the one thing that really mattered most is right here. It's not the start, because the start you can put any number you want. Domain of G doesn't matter. You put anything you want into the machine. It spits out anything it wants. It's fair call. There's nothing wrong with that. There becomes G of x, which is range. Okay? What really is the issue that we need to make sure that works, and that's why this whole exercise is interesting or it's new, is that before it goes to an f of x itself has restrictions for whatever function it is. So if it's a square root function, it can't take negatives. So if g of x happens to be a negative, then that machine doesn't work. Because at the end of the day, you need something to come out. You need h of x. That's what you need. Well, whatever g of x is comes out, it doesn't matter. Range could be anything. But f of x says, no, I'm not really that liberal, I only take a couple of things, okay? And these are the things I take. So before you can substitute g of x into f of x, there is a condition that needs to be met. And that condition is where we say range of G needs to be a subset of domain of f. This is where it's coming from, that's where it's sitting, but I want you to see why that is true. Okay, I'm going to show you with this example here why that needs to be true. And it's better if I had the other way around where f of x was actually square root, then you can see why it actually makes sense. But that's where it's coming from, okay? This is where it's coming from. We're trying to satisfy this condition, and if that's satisfied, then f of x will spit out anything. So we don't really care what it spits out. What we care about is whether it works right here. Because you put anything in, it spits out a number, that number goes into the second machine. If it can't fit, you're stuck. Because if it doesn't shoot out any other numbers, then it's undefined. There is no number. Okay, so a sort of a quick example for you to sort of see what I mean before we do an example is like this. Let's say I put into the machine, let's say it's x squared. Okay? But then let's say my second machine is square root of x. Okay. Actually, is that a good example? Let me think about it. Didn't they just cancel out? Let's just do x for now. There we go. Okay? I don't know if that will make sense. Let's say g of x is the first machine. Pick any number. Okay, we'll pick 2. I sub 2 in, so x equals 2. This is the domain of the first function, which I'll call g. Okay, so that's domain of g. That spits out a value. If this is my function, sub 2 in, it spits out a 2, because it's a linear. Spits out 2, so it spits out a 2, and this is now my range of g. It's a y value. I sub that 2 into the square root, and that spits out root 2. If I label them, this is the 2, which is your range, but also you're substituting into the domain of f. That spits out a y value, which is the range of f, which technically is the composite function, h of x. Okay? Now let's see where it doesn't work. So a linear equation, which actually looks like this. Linear equation could be anything. You can choose any x value you want. I just chose 2. So that means I chose this coordinate. And I chuck that coordinate into this machine, and that machine will put into this machine, and it spits out. But let's say I chose a coordinate on this side now, a negative coordinate. So I say negative 2. So negative 2 is okay for g of x. So I take this value, and remember this is now a y value. At -2, I've got -2. So my y value here, if I sub in -2, if I put x equals -2, it's going to spit out now -2. That's my y value, which is the range of g. But let's have a look. When I sub -2 in, this now gives you root of -2, which we know that's not possible. So root of -2, and then what is it going to spit out? This time you've got a domain. Yes, you have a domain for f. But what do you have for the range of f of g? There's nothing that spits out because root of -2 is undefined. So naturally, the question is, well, how do you make sure a composite function works? Or exists is the word we say it. How do we make sure it works? Well, we say, well, whatever it spits out, which is your range, as long as it satisfies the restriction of f, and the only restriction of f is the domain, because you're substituting into the domain of f. Whatever that number is, -2, you sub it in, doesn't work. -1, you sub it in, doesn't work. -0.5, you sub it in, doesn't work. So what works? 0, 1, 2, 3. That means on this graph, on this linear graph, the only numbers that would work are these coordinates. All these coordinates here with all those y values, all these y values will work. So that's why they say the range of f, the range of g, the first equation, the range of g needs to work for the domain of f. So that's why it says it's either equal to or a subset. So it's either up to it or less. It's a subset, meaning it's a part of. So if this is f, f can only take these numbers, positive numbers including 0. Then as long as g, range of g, is a subset. Because if it's a subset, it's within that number. It's okay. But if you have a number that's outside it, it doesn't make sense because then f can't complete the diagram. Yes, Josh?
Do you think like in the, like if you're writing f with g of x, you could write it as like root x, right?
Yes.
And then it would satisfy, like, it would have the same domain as the original f of root x.
Yes.
So then how come, like, we can say that the domain of f of g of x isn't, like, no. How do you kind of, right? I don't think most of these questions.
No, it does. What you're saying is right. Domain for f of g is equivalent to the original domain. The original domain was, we said there could have been anything, but the only way for it to work was that you only pick 0 onwards. True?
Yeah.
Because, yeah.
Yeah, no, we can say that one works.
Sorry? So in this case, it doesn't work if we don't restrict this domain. So the domain right now is domain of g, we would say, is R. What's the issue with R is it doesn't satisfy this section here. The only time it will satisfy this section here is if the domain was restricted to 0 to infinity to begin with. So you can pick any x value here to give you a positive y value. That will then restrict the range. So the range would now only be between 0 to infinity, and that happens to fit the domain for a square root function. And that now spits out, and that works. So this now machine does work, and that means the domain for g is actually the same as the domain for f of g, which is 0 to infinity, which is the square root function, 0 to infinity. Because it wouldn't work if I had -1. So if the domain for g, if I said, let's have -1 to infinity for a straight line equation, the issue is if I put in -1, if I put -1 in, it's going to spit out a -1, and that -1 goes into here, and that becomes root of -1, which becomes undefined. So that's an issue. So what you had to do was restrict the domain from the start so that the range fits. If the range fits the domain of the second function, you're good.
I just want to say is like, because you can write f of g of x as root x, right?
Yep.
And you would write f of x as root x. You wouldn't have to like restrict f of g of x if you're writing it as root x, because it's already implied, like the domain of, yeah.
All right. Listening, everyone? What Josh is saying is, I understand what you're saying. When you define a function, an implied domain is implied, so you don't see it. But when you define a function, you got to write the domain. So if you were to write f of g, right, and we're assuming it actually exists, because you can only write a function if it actually exists, if it's there. So if you're going to write that f of g exists and you wrote root x, okay, that's already an implied domain that you have 0 to infinity. You wouldn't write it like a function that doesn't work.
So like, because there's a lot of those questions in the book that are like, say why this function doesn't exist, but like we've already defined it as something that can exist. So like, it'll say like, one of the examples like, they have g of x equals x squared minus 1, and then they have f of x equals root x, where you can have -1 in g, but not in f of x. As a domain, so you think that's what should be considered like a function you had f of g of x. But like if you write f of g of x, then you like just looking at that and say that it works.
Yes, but you have to define the domain for f of g. So in our case, f of g was represented by h of x. All right, let's do a couple examples. All right, we'll do a couple examples to see if we understand. All right. Now, let's have a look. So this is the key part, what we're really trying to talk about here, for you to understand composite functions. We said that composite function will only exist, and when we say exist, it means you can plot coordinates if the following is satisfied, because this is where the issue was. If you remember the drawing I showed, you have one machine, second machine, this fits right here. If that is not satisfied, you can't draw the diagram, you can't draw the function. Okay? So that's what you're really trying to satisfy. You're trying to make sure range of g spits out needs to fit f of x. That's what you're really doing. Okay? So the example I gave in the PowerPoint, x squared minus 16, you can split this up into two functions. You got a square root function and you got a parabola x squared minus 16, right? So here we go. This is a square root function, f of x, domain 0 to infinity. I've drawn it. Second graph, g of x is x squared minus 16, which looks like this. Okay? If I asked you for the domain, you'd say the domain is all real values, so no issues, right? But if I asked you to write this as f of g or not, this is now written as x squared minus 16. This is your g of x. You're substituting g of x into f of x. So if we draw the machines, let's draw the machines again. This is x squared minus 16. This is root of x. What's the restrictions for the domain? Domain says you can only take 0 to infinity. So this machine here, which is the final product, you can only put in 0 to infinity. I'm going to write it on the side here, 0 to infinity. So that means whatever this machine spits out, I just got to make sure one thing. It has to be 0 all the way to infinity. It can't be a negative number. I wanted 0 to infinity. So whatever it spits out, which is my range, I want my range of g of x to be 0 to infinity, if not a subset of that. Okay? So let's have a look at my x squared minus 16. This is my graph. What it spits out is the range. What's the range of this graph currently? What's the range of g right now? What's the range of g? Negative 16 to infinity. So I'll write it out, negative 16 to infinity. Now that's a problem because the initial one didn't have any restrictions. The first machine didn't have any restrictions. It said, you can take any number, dude. Put any number. But the problem is, if I put any number I want, I put, let's say, a negative 2, that suddenly now gives me a y value. Negative 2 will give me a y value that's much less. And this number here is a y value that does not fit the domain. Because I said I want 0 to infinity. Let's see. Let's test. If I sub x equals to negative 2, negative 2 goes in, negative 2 squared is 4, 4 minus 16, negative 12. Suddenly I have an issue. So what will make it work? What will make it work is here. I want this. This is going back to similar to quadratics last year. You're trying to restrict the domain because we said we couldn't have -2. -2 didn't work. Well, what works? As long as you get a y value 0 to infinity, because that's what I said here. Oh, whoops, sorry. Where did I say it? Here. I said that I only take 0 to infinity for my range. That's my picture. From here is 0 to infinity for my range of G. So the question is, well, what domain would I have to restrict? Instead of having x element of R, clearly I can't. I can't take these values here. I'm going to color it in. I can't take that. Anything in here will give me a y value that's negative. So I want from here onwards, and I want from here onwards. So the question is, what is that? How do you find that? That's really just your x-intercept. So what you're really trying to find now is you're trying to say, all right, from here downwards, it should be okay. I choose any x values less than this point. It'll give me a y value that's positive. If the y value is positive, I can chuck it in here. It's all good. If I choose an x value that is greater than this point, then I will always have a y value that is positive. And it's also good. So now, instead of having x element of R, what should the element be? What should x be? And so that's why you're going to work the x-intercepts for what graph? X squared minus 16. Now if you find out the x-intercepts for y equals x squared minus 16, the x-intercept is when y equals 0. If you solve it, 0 equals x squared minus 16. Therefore you have 16 equals x squared. Therefore x must equal to plus or minus 4. So that means it's 4 and -4. Yes, Josh?
So you have to consider the function with the included domain within okay.
And that's what this whole exercise is about. Yes. Yeah. So this whole exercise now is fixing this. If you look at all the questions in exercise 1E, the exercise is just asking you to restrict this because initially that's what you're putting in. That doesn't work. If you restrict it now and you say, oh, look, you can do anything less than -4 or greater than or equal to 4, you should be good. Let's prove that. If I sub in 4 squared is 16, 16 minus 16, 0, square root of 0, perfectly fine. If I chose a number larger than that, let's say 5. If I sub in 5, 25 minus 16, perfectly fine, nothing wrong. So, in this whole exercise, what are you really doing is they're asking you to restrict the function that is inside the function. So let's look at it all again. I said f of g of x. What are you restricting? You're restricting this. You're restricting the domain. So I'm going to write here the domain. That's your skill in this exercise, is you're restricting the domain of G so that the range of G is a subset of the domain of F. And that's what this one property is about, and that's what's tricky about this exercise. But if you understand what I'm saying, this whole thing makes sense. You just picture the graph. Just look at it and see, well, what doesn't work? And clearly when I look at it, I already knew I just wanted that and above, and I found out my restrictions for the domain of G, and that works. So finally, let's say you figured out the whole restriction. How do you answer the question? It only works if you have h, because the function is h of x. This is only going to work if I have x's between, what was it again? It was negative infinity to -4, union 4 to infinity, maps onto R. What's my h of x? h of x equals to x squared minus 16. That'll be fine. And you can type that in your calculator with that restriction, then it'll sketch it. But if you don't type in that restriction, that's not going to work. And remember, what is this? Hey, I can write on the screen. Hey, look at that. I didn't realize. Didn't remember. When did that happen? Anyways, remember, this is the domain, restricted domain of G. That's what you were doing. You're just restricting this. You change this so that it works. You're only taking this section here. And that is negative infinity to -4, union 4 to infinity. That's what you're doing. This whole exercise 1E. Okay? Your aim Let's get that. That is why the second property says that domain of f of g is equivalent to the domain of g. Does it make sense? It's what you're putting into the machine. And in our case, we can only put these numbers into the machine so that it works. So the domain of g has to be the domain of f of g. The reason why I'm teaching you the understanding of which is the machine and which one goes in and which one goes out, because I don't want you to memorize these formulas, because it changes if you did g of f. See, g of f now is the flip. It's the other way around. Domain of f, this would mean that you would want now the range of f to be the subset of the domain of g. It's switched around. So that's the difference. And that's what the examiners will try to trick you if you don't understand what you're doing. Okay? Because they know students memorize this. So they just switch it. And they say, does f of g or g of f exist? And your job is to prove whether it exists or it doesn't exist. And what you're looking for is the domain where that fits or not. Okay? How do we feel? Does it make more sense now? Yes, no? Hands up if it does. Hands up if you like an example. One more example. All right, cool. I'm gonna just have a look at the PowerPoint, and after this, what I want you to do is practice for this session, and then we'll go into inverse functions. Okay, it's the second half. But for now, let's practice. Let's practice. What is this? No, you don't need to know that. That was me describing it, and we can do this example, you and I. Okay. All right. The rest, work on exercise 1E. In the second half, I will go into inverse functions. Okay, practice 1E, 1F. Those are two important exercises that are definitely going to be in the exam, especially 1F. Inverse functions, I promise you, is going to be there every single year since, I don't know when, 1996.